Okay, so hello and welcome to this last module for week 6. So, we are at lecture 30, which is and the topic of this particular module is on life cycle assessment. We started talking about life cycle assessment towards the end of the previous video, if you remember that. And then we will continue that discussion, we will look at some examples. So, this next 30 minutes or so, I will give you a overview of what is an LCA, why the LCA is done, how it is done, little bit of history behind LCA, how it all developed and its application in different environmental decision making. So, so that would be what we will cover in the next half an hour. There is an LCA course on NPTEL which was offered like almost 2 years ago now. It was rerun also once. So, the videos are available on YouTube. So, you can go and watch it if you want to learn more about it. If you just go on YouTube and search for life cycle analysis with my name, you should be able to find it. And that was an 8-week course. So, it was almost like it was 40 lectures. So, it's not a, it's a detailed, it's a long, what we are trying to do in this half an hour is just giving you an overview of that. So, as this is an introduction course anyway, this EVS course. So, life cycle thinking, that is what we were kind of in broad view, that is what it is. Having a life cycle thinking, what does that mean? Life cycle, as in a biology class or in your EVS textbook that you had in your school, you may have learned about life cycle of a bee, life cycle of a frog. So, what is that life cycle? Is starting from very beginning to the end. So, from cradle to grave. Cradle is when something is born, like when the baby is born, we put it in a cradle, and then when one of our near and dear ones pass away, we put them in, say this concept came from the Western world. So, they have that grave concept where most of the people are put in a grave. In different religions, different cultures, things happen differently. So, but that is basically beginning to the end. So, whenever we like for any particular product or process, we are looking at its entire life cycle from beginning, like getting the raw material, all the way to its disposal as well as resource recovery. So, that is what we are going to focus on. So, if you look at the detail as listed over here, you start from the very beginning, like having the concept, like even at the very beginning, what is the concept of this like a product or process, the material and material extractions, what kind of materials will be required, what is the toxicity of those materials, try to use the greener materials. Then you have to make the manufacturing and packaging, transportation, retail use, in between you have to clean them as well. So, there is a cleaning activity depending on the product, and finally, disposal, landfill, incineration or whatever, or recycling. So, the entire thing from the very beginning to the very end is what is known as the life cycle. So, it is the life cycle analysis. So, what we are doing here, this whole exercise is like an environmental accounting exercise. So, when I say environmental accounting, it is essentially you are looking at all the resources that are being used. When I say resources, it is the material including water, energy, which goes into making the things, making any like as a part of any process. And then what are the emissions? Emissions will be any water pollution, air pollution, solid waste, hazardous waste. Those are your emissions which coming out, which needs to be managed. So, this entire things together is known as the life cycle analysis, the life cycle thinking, and we will look at some of the examples to make it more clearer for you. And as I said, if you are really interested in this topic, you should look at those videos which are available. So, whenever you go for this life cycle thinking, why we have this concept of life cycle is important. If you look at this image, which is like image, in fact, you might have seen it on Facebook and other places, because that is where I got it from, somebody put it up there. So, it is on the top, it says it is a diesel vehicle, and since the emissions are coming out from the diesel vehicle, as you can see over here, people are like, oh, it is dirty, it's creating so much of pollution. So, you see that those pollutions being created. So, that people feel, the driver inside is feeling that I am contributing too much to the pollution that is happening. So, he or she replaces it with an electric car. Now, he has an electric car, not much emissions on the road, but electric car requires charging, and if the charging is happening using the coal based thermal power plant at the background, you are not really doing anything good. So, what you did is what is known as problem sifting rather than problem solving. So, you sifted the problem from the roads to those thermal power plants, coal based, if it's coal based thermal power plants. So, the emissions will be the same, could be more. You could be actually end up doing more emissions in this electric vehicle as opposed to the diesel vehicle. You may, depends on, you have to do the calculation, but or you may not, you may have a little bit less, but what you have done is not really solve the problem. So, if electric vehicle with the renewable energy source like thermal or solar, wind, hydroelectric may be better, but if we are using at present, for example, from the Indian context, nearly 60% of our energy is coming from coal based thermal power plant. So, with this coal based thermal power plant being the source of energy, switching from petrol diesel vehicle to electric vehicle is not really going to do any good. It may feel good, but if you do the math, if you do the calculation and find out what is the real environmental impact, you will find the environmental impact is more or less the same, and it could be more because the batteries requires a lot of metals and a lot of rare earth metals, and to extract those rare earth metals, it requires mining, and mining is a big environmental footprint. So that is why this concept of life cycle is very, very important, because we need to look at, it is not just solve. If we had looked at from the cradle to grave with electric vehicle, from the beginning, making of the electric vehicle, usage of the electric vehicle, emissions that is happening because of the charging of the by the batteries of the electric vehicle, we will know the true answer. So that is why this concept is very, very important. Many times you will you get something which sounds environmental friendly, but they may not be environmental friendly, because you need to really do the calculation to find out, is it really environmental friendly. And this is one example. In California in 1990s, which would be kind of similar situation. In fact, California in 90s was slightly better than what we are in India right now, but California in 90s, they did a calculation on same exercise, and they found that unless they move towards predominantly renewable energy as a source of energy, electric vehicle was actually not really going to do much good to the environment. So it will be almost the same, and in some cases even worse. In Texas, they have done another study which is out there, which also shows that Texas, being the gasoline produced like petrol, diesel is there very close. So, they do not have to transportation and other stuff, in the environmental footprint based on transportation is not that high. So, they found that actually electric vehicle comes out to be worse in Texas than gasoline driven car. So, you have to do the math, you have to do the calculation, then only that's the reason why this is very important. Probably that is the reason that EIA was one of the step in terms of finding the environmental impact. LCA gives a much broader view, EIA only gives a narrower view. So, we have to go beyond EIA, we have to go to LCA, life cycle analysis, life cycle costing analysis and all that, to really understand what is the real impact on the environment. And in Indian context as well, most of these like foreign funded like World Bank, ADB and those funded projects, they require LCA now. Many countries like LCA is mandatory. Western European countries, LCA is a mandatory. So, if you know LCA, how to do life cycle analysis, you actually have an edge over other people in terms of your job and all that, because every company nowadays needs to have a sustainability office, and they are going into this life cycle analysis, life cycle thinking, which kind of links to that circular economy concept as well. So, those are very, very important stuff today. So, again, if you are interested, go and look at those YouTube videos which is out there, but we will try to explain, give you an overview. So, avoid these kind of decisions, although many times it feels so good that, oh, we will have all electric vehicle in 5 years from now or 10 years from now. Great, but at the same time we need to make sure that our energy mix is also predominantly renewable rich. so that you can really make a good judgment on that. And the renewable energy also needs to do life cycle analysis there as well. Solar panels requires a lot of heavy metals, rare earth metals. So in fact, one of the master student right now in our lab is trying to do that. So we'll probably in a year from now we'll be able to share some data, that whether how good is solar panel as opposed to other forms of energy. Is it because it should be good, but how good is it? Has 1/4 of the environmental footprint compared to thermal, half, 1/10. So it's because whenever you move, there is a transition. There is a disturbance, and many things you lose as well, because say if you start producing all these electric vehicle, what will happen to all those petrol pumps, and what will happen to the people working at the petrol pumps. So all those things needs to be thought into before you make any decision, and unfortunately many times we don't. Like many times the government makes those decisions, it's an impulsive decision rather than scientific basic decision. So we'll talk about this. A lot of examples you can look at in again that LCA course. So, but whenever we talk about this concept of we are looking at this LCA, what we are trying to do is go from cradle to grave. That's the concept. We are going from cradle to grave concept. So we start from, say for example, here there is an example here for a T-shirt. We all use T-shirts. So now if you have to do a life cycle of a T-shirt, and as you can see on this sketch, the numbers, there are 1, 2, 3, 4, 5, 6. So it starts from 1 and kind of goes in a cycle. So number 1 is that the eco design, that somebody is coming up with a design, say it was designed in USA, so they thought about the design of it. No, only some thought processes went in there. Then the raw material came in number 2 from Turkey. Turkey produces good cotton T-shirts, cotton stuff. So you got from cotton from Turkey, transported it, produced it, and you took it to a factory in US, for example. And that could be anywhere. It could be India, it could be Bangladesh, it could be Malaysia, because most of these days textile industry, good quality shirts, if you go in abroad and look at in the malls, mostly Bangladesh, Malaysia, some India now, but earlier it used to be more India, but nowadays it's less Indian, more Bangladesh shirts showing up in international market. So then it is produced in USA, for example, in a factory. Then it gets sold in Europe, got exported by some company to Europe. People use it in France, and then they use and they dispose it. So now in terms of the life cycle impact, the raw material from Turkey transported to US, so there is a transportation, factory making in US, so there is an impact there, then transported to Europe for sell, and people buy in France and using it in France, so there is a cleaning of it, for say for example T-shirt is life is 100 times you wear it, 200 times you wear it. So 200 times you wear, average like 180, 199 times you will clean it. So how much water is required for cleaning that? So all those things are accounted for. So that's why it's an exhaustive exercise. That's why you need software to do that. So there are softwares out there which do that, which we'll talk about a little bit as well. So and at the end of life, it will get disposed, where it may go to a compost plant, it may go to a waste to energy plant, it may go to a landfill in Europe, or say if it got donated to somewhere in Africa, it kind of ends up in Africa or in Asia, then it gets dumped in Asia. And then so that, but in terms of its life cycle, we have to try to track how it was made, how it was used, how it was disposed, and then put a overall environmental impact associated with that. So here we are trying to capture all the aspects, so you avoid in terms of problem shifting, which you saw in the previous picture. So assumption that we make about what is green and what is not, usually it is based on our experience, upbringing, media, education. So you hear something, something may not be 100% correct, but if you hear it say 100 times on your TV, you feel like, yeah, maybe it's correct, because so many people are saying that. So, but it's not really correct. So, it's because it's you have to look at the facts. So, but usually it's based on experience, upbringing. We feel like, oh, recycling is good. Yeah, good, but how good? Say there has been studies we have shown that aluminum can, for example, which is recycled a lot, and aluminum cans, if you have to take the aluminum can and transport it more than 300 kilometers, the amount of energy that you use in transporting that aluminum can is actually more than the energy saving or the environmental saving that you will do by recycling it. So, if you have to transport a longer distance, recycling feels good, but it's not really doing any good to the environment. So, often it is not based on scientific understanding. It's that's what I was talking about even in the case of electric vehicle. It's not based on scientific understanding. Many times what happens is, especially in this personality driven system that we have, personality driven policy making that we have in many countries, not the system driven, not scientific basis is present there. So, based on there is no science basis, but things gets decided just because somebody wants to have it that way, and that's unfortunate, but that does happen, and not only in our country, happens in many countries. So, but we have to get away from there. We have to get this science ingrained into our policy making. So, that's very, very important. Those of you who are out there listening to it, taking this class, even you are in a position like that, do advocate that science should be there in the policy making. That's if it's there, then it will really make sense to do certain things, which many times we do things and we fail because there was scientific basis was not there. Often lead to impact transfer, not impact reduction. You saw that picture, electric vehicle versus gasoline vehicle, fluffy good, feel good feeling on what's green. You may feel good about that, but it's actually not really doing any good to the environment. So, what it's not really, is it really worth doing that? Putting a lot of trouble out there to people and to resources, to everything, and setting up new infrastructure, which will also have a lot of environmental footprint. And then ultimately we are not doing any good to the environment. So, which was the motive behind doing it. So, that's what we need to look at. So, life cycle assessment is you need to have a systems thinking. So, it's sometimes not easy to grasp. So, you need to have a systems thinking rather than silos thinking, not in like just you have to have a broader outlook, like holistic view of every problem. So, to do this, since it's a tool, it's a method, it's an analysis, there has to be a standard protocol. So, that if I am doing it here and somebody else is doing it in another part of the world, we should be able to compare our results. So, that's done by ISO method. So, ISO method is out there. It's a technique for assessing the environmental aspect and potential impacts associated with a product, system or service. So, that's what it is called. So, what is sustainable? So, there are three pillars of sustainability: environmental, economics and social. So, all three together is what is known as the sustainability. Out of that, life cycle assessment focuses on the environmental aspect. Then the social and life cycle costing assessment does the economics. Social LCA is out there to do the social part of it. So, what we do in LCA, it's compilation and evaluation of the input, outputs and potential environmental impacts of a product system throughout its life cycle, as I was trying to explain to you. For example, if you look at this is carbon footprint of circular bioenergy system, say in the sugarcane field, from the field to the sugar mill to the lactic acid plant, you make lactic acid and you take it to the customers, you produce sugar, and you use it in sell it as a sugar. Then you have certain byproducts, which is back to the soil as an agriculture as a soil conditioner. So, if I want to do a life cycle analysis, I have to essentially take this entire thing together. I have to take this entire thing together and then come up with, say, okay, total carbon footprint is actually minus 224 kg per CO2 per ton of lactic acid. Why minus? Because there is a carbon sequestration happening here. Carbon is being captured rather than carbon being released. So, here we are from the sugarcane fields to lactic acid product plant and lactic acid, and if you just make the sugar, these numbers will be different. So, do not coat it for the sugar manufacturing. This is actually when we are doing this lactic acid plant, where we are also using it as a soil conditioner. We are not producing any waste. We are trying to reuse the stuff within that. So, that is why you see a negative number over there. So, because carbon is captured as well during the agricultural operation. So, but it is not always negative. So, do not take it that not all agricultural based stuff is negative. So, how we do it in LCA, there are 4 steps: define goal and scope. You come up with inventory where you get all the data, and you come with impact assessment, interpret this study. So, this is again coming from ISO document: goal and scope, inventory analysis, impact assessment, and interpretation. You see the arrow on the back both sides. That means the phases are iterative in nature. So, you kind of go back and forth. You do once, you learn something, you go back and do again. So, you collect more data. So, things are iterative in process. So, in terms of goal and scope, we have to find out what is the purpose of the LCA and who is the audience, what is the target audience. In terms of inventory analysis, we look at the functional and functional unit. What is the function that product is giving? What is the functional unit of that product will use? System boundaries, data that you require, assumption you make, are there any limitations? And then I will explain with a problem, and you will understand what is the function and functional unit is. Then you go for impact assessment in terms of what is the environmental impact. In LCA, we focus on environmental. Social LCA is different, economic LCA is different. We talked about that. Then why we did do all that? To find out how to reduce environmental impact, what conclusion we can draw, what recommendation can be made. For example, if you compare wooden pencils versus mechanical pencil. So, for both does a function of writing. So, in both of them we do the writing, but in terms of writing, when you try to compare the two, you cannot compare one wooden pencil versus one mechanical pencil, because wooden pencil will be used up and will be gone. Mechanical pencil, you can keep on changing the lead and then keep on using it for a longer period of time. So, it will be unfair comparison of comparing both of one mechanical versus one wooden pencil. So, but what we can compare is what the job they do. They help us in writing. So, we can say 10 pages of writing, 100 pages of writing, 20 pages of writing, whatever you can choose that. So, that becomes your functional unit. Now, you do all those resource allocation, you do all those calculation based off that functional unit. So, if you look at this example over here, wooden pencil, what it will require? It will from the lumber forest, lumber to the paper mill, manufacture, retailer, use, and end of life, and it will be gone at the end of life. So, throughout the process there is a transportation, that is the T is the transportation, and then you have different materials that are being used. So, you have to get all the data in terms of all the material, energy, water, all those things that was used in this, and the emissions which came out of that, and use it for this life cycle inventory. That is called life cycle inventory, which we just mentioned a little while ago. Mechanical pencil, similarly you will get oil to polypropylene, rubber, graphite, packaging, manufacturing, retailer, use, dispose, end of life, and in between transportation is involved. So, this becomes your system boundary for mechanical pencil. So, now we can say that 20 pages of writing using either mechanical pencil or wooden pencil, and then compare that. What is the environmental footprint of these two? That would be a fair comparison. So, function is the service provided by the system. What it does. Functional unit is give the function a number value, allows comparison between products, reference point. So, as I said, function for this pencils is writing. So, it could be 1 meter of writing, 100 meters of writing, 1000 meters of writing, whatever we choose, but it has to be the same for both. Items that we consider: energy, material, labor going into the system, the product, waste, emissions, and co-product that is coming out. So, that becomes in terms of your different things that you need to consider. Another example, china plate versus paper plate. Here, as you can see, what is the function? To serve the meal, isn't it? To serve the meal. What is the functional unit? You can choose, say if we want to for a month, say just the dinner for a month. So, 30 serving of meals. So, we need one china plate washed 29 times, hopefully. In some of the hostels, the students will eat it without washing too. I am just kidding, but it's washed 29 times. So, when you wash it, dishwasher, hot water, detergents, all those things needs to be taken into account. If it is a use and throw plates, paper plate, you need 30 different plates. Again, no use of second use of the same plate, because it is not hygienic to do that. So, functional unit is your 30 meals. Material resources, we have to find what does it take to produce, impact to the environment, is there a waste, washing the china plate, what types of data you will require. So, all those things goes in there. So, once we have all those data, once we get all the emissions data, we try to find out what is the impact in terms of the global warming potential, a biotic depletion, human toxicity potential, all those different impact. So, that is what the impact category is all about, and then we try to compare. So, let us look at another example which is a little bit in detail, that will make it more clearer for you. We will look at the example in a minute. Okay. So, once you have this environmental impact categories, then you try to what you will do with that. So, what is the purpose of all this data, what you will make sense of all that. So, what you do from there, like you look at all the different environmental categories, you looked at some earlier, the eutrophication, acidification, these are also other environmental categories. And once you have these environmental categories, you take those data and try to make sense in terms of recommendation for the choices that is less impactful. You can analyze a particular impact and focus on solution. Industry and individual can take a closer look and how they can make a difference, how to make the product better. So, those things can be done from there. So, let us now look at that example where we are trying to compare this compact fluorescent versus incandescent lamp. Which one is better? We know for that CFL will come, CFL is better because it is energy intensive, but how much better? So, if you want to do that, what you will do? Life cycle of a product, life cycle of this bulb. So, you start from resource acquisition, manufacturing, distribution, use, end of life, and throughout this process, what is the impact on the Mother Earth? So, that is what we are looking at. What is the impact on the Mother Earth that shows up over there? So, all process associated with the products wherever and whenever they might occur. So, we kind of try to do that. So, if you look at the life cycle of a light bulb, you start from this bulb, then the bulb has to be made. So, all these the raw material that are coming in. So, glass, tungsten, copper, steel, aluminum and all that. So, that is the raw material which is needed to make the bulb. Then this material has to come from mines and some other sources. So, extraction and transformation. So, that is called resource acquisition, and this part is the middle part is the manufacturing. Once the manufacturing is done, then you have to distribute. So, distribution has like packaging, transport, those will be involved. It will come into the use phase where people will use it using some form of energy. Then you will have end of life where things have to be disposed in a landfill or incineration and all that. So, overall all these, the dotted line that you see is what is known as the systems boundary. That is the systems boundary, the boundary within which we will do all our calculation. Now, bulb, what is the function of a bulb? Primary function is to provide the light. There could be some secondary function, but we will not worry about that too much here. Its primary function is essentially to provide a light. So, when we do an LCA, we try to find out what is the environmental impact from all these different activities we just listed for that particular bulb. What is the disturbance to natural cycles, what is the change in the state of natural environment. Then we go for all LCAs accounting for all environmental intervention associated with life cycle of the product. So, we resource acquisition, manufacturing, distribution, use, end of life. There are a lot of inputs coming to the system, natural resources, water, energy, output in terms of emissions, other environmental output as well. So, all these things needs to be factored in when we go for LCA, and we do it for that functional unit. Now, for this bulb, there are two types of bulb. We have to choose a functional unit. Functional unit, as we said earlier, it is a product comparison is based on functional unit on comparison basis. We cannot simply compare product A versus product B as I talked to you about the mechanical pencil and the wooden pencil, or here CFL versus incandescent bulb. For example, comparing milk cartons and a returnable milk bottle, maybe the best way to compare could be packaging and delivering 1000 liters of milk, either of those two options. So, in terms of here, in terms of the bulb, the function is lighting. So, primary function is lighting. Secondary function is a heating, creating an ambience. We will not worry about that right now. And So, functional unit, let us choose that we will provide 700 lumens for 10,000 hours. Now, why I am choosing this? Because that gives me 10 bulbs of 600 kilowatt hour of electricity for incandescent and 1 bulb of 14 kilowatt hour for compact fluorescent, for CFL. So, this gives me an easy number 1 and 10. So, it is easy for me to do the calculation. So, that is the reason I put 700 lumens for 10,000 hours. So, this functional unit is in your hand and what you want to choose, but it has to be same for the different products or different processes that you are going to use. For example, in a wastewater treatment plant, if you want to do it, you can have 1 kg of COD removal or 1 meter cube of wastewater treated for a similar type. So, COD will make more sense. So, like a 100 kg of COD removal or 110 kg, whatever, you can come up with that, and based on that you can compare, and then you can look at the lifetime watt lumen ratio. Will not worry too much about that here. So, you have to go next for the inventory to come up with a list. So, inventory for the light bulb, you have a product system, you have the bulb, you have the cardboard, you have the energy source. So, functional unit we said 700 lumens for 10,000 hours. So, then next step is, okay, so for these functional unit, how much in terms of the bulbs, how much glass will be required, how much cardboard will be required for packaging, how much energy will be required. Now, glass, and there are a lot of other materials too, just the example materials are presented here. When you make 1 kg of glass, 94 grams of crude oil, 1 gram of iron ore, 1300 liters of water. What are again, these are not complete list, these are just snapshot, these are just like some example numbers provided there. The long list is long and long, that is why we use a database, we use a software. The output will be emissions, CO2, PM 2.5, benzene that is coming out. Similarly, can be done for cardboard. As you can see here, if you look at just the water footprint for 1 kilowatt hour for thermal power plant, 19,000 liters of water is required. 1 kilogram of cardboard, 3200 liters of water is required. So, water footprint is pretty high for this, and then emissions for all those. So, we get all this data, we get all this data. Now, this the unit process data which we are looking at here is provided in for 1 kg, but we have to find out for our functional unit, which was we found that 228 grams of glass, 232 grams of cardboard and 600 kilowatt hour is required. So, we will just do the simple math and convert these numbers to those numbers like for per functional unit. So, for 1 kg this much, so how much for 228 grams? For 1 kg this much, so how much for 232 grams? For 1 kilowatt hour this much, so how much for 600 kilowatt hour? So, we can calculate these numbers. So, this is the number we require in terms of the impact assessment. So, we use those numbers for impact assessment. So, we get we get lots and lots of inventory data, very hard to interpret sometimes. Brain can simultaneously only consider 7 independent variables. So, we try to neglect some impact too, which is less than 0.1% of environmental load. Luckily for us, there is a database available, several country-wide database is also being developed. In India also we are developing LCA database. In fact, my research group is involved in doing some of those stuff too. So, we are doing but this data that database that you are seeing, which is a most exhaustive database available today, is developed by ecoinvent.org. It is a Swiss organization. So, there are different organizations, they have come together and made this central database. So, data for all different activities, as you can see, agriculture, energy supply, chemicals, transport, metals, plastics, all those things are available. But this is based on Western Europe, based in Switzerland, but if things do change from place to place. So, US government has their own database, Canadian government also has a database, not as exhaustive as this one. India, we are trying to have our database. So, those things are also being developed. So, once you have this, let us go to the next slide first. Yes. So, once we have this LCI result, we go to try to make a sense out of that, which is called a midpoint. We look at the midpoint impact of different impact categories, and from the midpoint we go to this what is known as the endpoint impact. And the reason for doing all this is ultimately the major goal for us is to come up with a better product. So, you as a country, as a company, you do LCA, you come up with either eco design, strategy development, product development, benchmarking, you can go for life cycle costing. So, this is you can look at energy and material sector specialists, LCA expert, designers, product managers, all that come together and they can design a product better, which is in more environmental friendly. So, that is the whole concept of it. So, once you have these impact categories, you can come up with a single score, because say if you have to present it in front of a audience, like you have to give a presentation in front of the policy makers and other places, giving them all this global warming, ozone layer depletion, all those different categories may confuse them. So, it is always better to convert that to a single score, and that is it's done. And like I said, very similar to BSc Sensex or water quality index, air quality index. Similarly, you can come up with a single score, and then there is a method to do that, and then you can use that single score in terms of interpretation. So, from elementary flow we get the impact categories, then we looked at the damage categories, and then we come up with our single score, and then we try to interpret and all that. So, this is how a LCA is done. And in terms of history of LCA, the first one, which was not really LCA, but similar study was done by Coca-Cola long back in 1969. Then nothing much happened, but as you can see from 1997 onwards, lots of activities are happening on LCA. This is an upcoming area, very popular area. If you have an LCA, if you know how to handle LCA, it's a good tool to have in your CV. So, how we use it? There is some example here, Peel region, Auckland, New Zealand, we are evaluation and then some other projects. So, for example, here different waste management infrastructure. We will talk about waste management later in this course. So, say if you have a what you can understand from these graphs right now is, say if you have different options in which you want to manage the waste, you can do LCA on those different options and come up with which option is most environmentally preferable. So, here there is one option was there, another option, and then another option. So, we were just trying to compare. This was done few years back, and then we were comparing the different options in terms of the environmental footprint. Similar thing, we were involved in a project in Auckland, New Zealand, where we looked at should we go only for landfill, should we do composting, should we do anaerobic digestion after composting, or we should do anaerobic digestion followed by again composting. So, there are different options we were trying, and then we found, and especially these were for the food waste, we looked at the different options which is better in terms of the environmental performance. So, that is kind of a very quickly overview of what we try to cover. So, this week our focus was on looking at risk assessment, basic concept, how we do environmental risk, how we conduct EIA, and last in this particular video we focused more on how it is LCA, how it is done. As you probably like, it was a bit we had to, since it's as I said, it's almost a course. What I covered in half an hour or slightly more than half an hour is essentially a very small summary of a 8-week course, which is already there on NPTEL and YouTube website. So, you can find it more information there if you are interested. Hopefully, that course will also rerun sometime in future, sometime in near future. But again, any question you can put it on the discussion forum, we will be happy to answer. And thank you, and hope you are enjoying this course. So, we have finished 6 weeks. So, halfway done, another 6 weeks to go. Thank you.